When performing a service change and using a junction box to splice and extend branch circuits, the installation of the water pipe bonding conductor requires careful attention to ensure compliance with electrical codes and safety standards. According to Section 250.148 of the National Electrical Code, all equipment grounding conductors, grounding electrode conductors, neutral conductors, and grounding conductors of outlet boxes and raceways must be connected together at the service. This requirement applies to all enclosures that are part of the electrical system, including junction boxes. The junction box becomes part of the equipment grounding conductor path, thus, all grounding conductors within the junction box must be connected together. This ensures a continuous and effective path for fault current to return to the source, facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. Connecting all these grounding elements together within the junction box maintains the integrity of the grounding system. If the water pipe bonding conductor lands on the grounding bar in the junction box and continues to the water pipe system, it changes the intended function and effectiveness of the water pipe bonding conductor. The water pipe bonding conductor serves as a grounding electrode conductor connecting the electrical system to the water pipe system, which acts as a grounding electrode. By landing the water pipe bonding conductor on the grounding bar inside the junction box, a parallel path for grounding current is created. This parallel path can diminish the water pipe bonding conductor's effectiveness as a dedicated grounding electrode conductor. The primary function of the grounding electrode system, which includes the water pipe, is to provide a stable reference to earth potential. This helps to limit voltage surges and provide a path for fault current to dissipate into the earth. By introducing a parallel path through the equipment grounding system within the junction box, the intended path of the fault current is altered, potentially reducing the effectiveness of the grounding electrode system. Instead of landing the water pipe bonding conductor on the grounding bar in the junction box, it should be connected separately using a suitable grounding clamp. This method ensures that the water pipe bonding conductor maintains its direct connection to the water pipe system, preserving its function as a grounding electrode conductor. The grounding clamp should be listed for the purpose and properly sized to accommodate the conductor. The connection should be mechanically secure and provide a low impedance path to ground. It is important to ensure that the grounding bar within the junction box is properly sized and rated for the application. The grounding bar should be securely bonded to the metal enclosure of the junction box to provide a continuous grounding path. All grounding conductors should be connected to the grounding bar using appropriate connectors, such as compression connectors or screw-type connectors listed for grounding purposes. The size of the grounding conductors must comply with the requirements outlined in the National Electrical Code, specifically Table 250.122, which provides guidance on sizing equipment grounding conductors based on the rating of the overcurrent protective device. For example, if the circuit is protected by a 20 amp breaker, the minimum size of the equipment grounding conductor is 12 AWG copper. If the circuit is protected by a 60 amp breaker, the minimum size of the equipment grounding conductor is 10 AWG copper. If the circuit is protected by a 100 amp breaker, the minimum size of the equipment grounding conductor is 8 AWG copper. The grounding electrode conductor, which includes the water pipe bonding conductor, must also be properly sized according to Section 250.66 of the National Electrical Code, which bases the size on the size of the service entrance conductors. For example, if the service entrance conductors are 2/0 AWG copper, the minimum size of the grounding electrode conductor is 4 AWG copper. If the service entrance conductors are 4/0 AWG copper, the minimum size of the grounding electrode conductor is 2 AWG copper. When dealing with a multi-wire branch circuit, the grounded conductor, often referred to as the neutral, must also be connected to the grounding bar within the junction box. This connection ensures that the neutral conductor is properly grounded, providing a return path for unbalanced loads. The size of the neutral conductor should be in accordance with Section 220.61 of the National Electrical Code, which outlines the requirements for neutral conductor sizing. In summary, firstly, ensure all equipment grounding conductors, grounding electrode conductors, neutral conductors, and grounding conductors of outlet boxes and raceways are connected together at the surface within the junction box. Secondly, avoid landing the water pipe bonding conductor directly on the grounding bar. Instead, use a separate grounding clamp to maintain its direct connection to the water pipe system. Thirdly, properly size and rate the grounding bar and grounding conductors according to the National Electrical Code, referencing tables 250.122 and 250.66. Fourthly, ensure all connections are mechanically secure and provide a low impedance path to ground. Fifthly, when dealing with multi-wire branch circuits, ensure the neutral conductor is properly connected to the grounding bar. By following these guidelines, the integrity and effectiveness of the grounding system is maintained, promoting electrical safety and code compliance.